All right, so this is the final exam chapter review for chapter 5, and it has to do with factoring. So first off, we look at a trinomial such as this right here, and notice that the leading coefficient is 1. So what we do, and as it says here, we're factoring of this form. Leading coefficient is 1. So what we do is look at the factors of the last term, C, and find the ones that sum up to the middle term of B. So just bear with this slide. As this was saying, we're looking for two integers with a product of 10 and a sum of -7. So what we would look for is pairs here. So 10 and 1 gets us to 10, but when we sum them, it gets us 11. -10, -1, but gets us to +10, but when we sum them, it gets us to -11, which is not -7. 5 and 2 do get us to +10. They get us to 7, but we need a -7. So we're going to continue on looking for pairs of numbers. Notice -5, -2 gets us to +10, and we can sum those up to get -7. So there we found our factors. So what we do is move directly into the factored form here, b minus 5, b minus 2. And anytime we do factoring, we should always check it by FOIL, which we do here. And that ends up with, notice what's happening with the inner and outer there. They're summing up to the middle term of -7. So there we go. So now we're looking at factoring a trinomial in the form ax squared plus bx plus c. Notice that the leading coefficient is not 1. So if you remember, we use something called the AC method here. So remember, A is 6, B is -19, C is 10. So when we find the product AC, which is A times C, so AC is 60. So we look for factors of AC that also sum up to -19. And as I showed you in many examples, what you would typically do is list out your factors over on the side, and then you would do an analysis to just determine which ones add up to the middle term. They kind of leave that out in this particular portion, but we'll look at an example later where we actually do the whole process. But let's just assume that we found those factors, -15, -4. -4 times -15 does get us to 60, +60, and -15 plus -4 does get us to -19. So what we do is rewrite the middle term, -19k, as -15k minus 4k using the factors we found. So we rewrite that -19k. We're unfoiling, right? So the inner and outer terms are what we've just created there. So now that we've rewritten the middle term, what we do is group into two groups, the first two terms into a group, and then the second two terms into a group, also separated by a positive sign. Now what we're going to do is take out the greatest common factor out of each group, and in the first group, that is 3k, and in the second group, it's -2. Notice what we have created here. We have created the common factor of 2k minus 5 within both of these terms, right? So what we do, the magical step that happens is we factor out the 2k minus 5. So we've just factored this trinomial here using the AC method. We got 2k minus 5 times 3k minus 2. The next type of factoring is the difference of squares. If you remember from section, I think it was 5.4, anytime we have a binomial, the first thing we check is to check and see if it is a difference of two squares. And we apply this formula to factor it. So here we are, we got factor each polynomial. We got p squared minus 100. Notice that that is a difference of 2 squared, p squared minus 10 squared. So we apply our formula there, p plus the square root of the second, right, times the square root of the first minus the square root of the second. There we go. So we've just factored that because that is a difference of 2 squares. Now b doesn't look like a difference of 2 squares, but when we take out the greatest common factor of 2, notice we have created a difference of 2 squares here. We've got a perfect square of 9. So x squared minus 9 is a difference of 2 squares. Remember, we use the difference of 2 squares formula here. The square root of the first plus the square root of the second times the square root of the first minus the square root of the second. That is the difference of 2 squares. All right, so the next thing we want to talk about in this chapter is the zero factor property to solve an equation such as a quadratic. So notice it says solve. So some of these problems are just going to ask you to factor, and some of them are going to ask you to actually solve. The big hint when it says solve is it will be equal to 0, or you'll have to get it into standard form to get it equal to 0. But notice sometimes when it says to just factor, it'll just be an expression. But let's just look at the zero factor property from its very basic when we already have it factored into two binomials here. So if you remember the zero factor property, what we can do is take each one of these factors and set them equal to 0. Then we solve each corresponding equation, which we can do very easily on the left by subtracting 3, dividing by 8, and on the right, subtract 1, divide by 2. So I've just solved that quadratic there by using the zero factor property. And then you would always check them into the original equation. And then remember, we put those two solutions into a solution set. So using set notation around the two solutions that we got to. So sometimes you can have one solution, 0 solutions, or 2 solutions for a quadratic. I think typically what you're going to run across the most often is 2 solutions for a quadratic. That's the zero factor property. So let's just look at it in a situation like this. So the first thing we do is we got to get this quadratic into standard form. And the first thing we do to get it into standard form is subtract 4 from both sides. Now we've got the quadratic set equal to 0. So now what we're going to do is factor this quadratic. And we would use the procedures that we outlined before in section 5.2 to factor the quadratic. So now that we've got it factored, what we do is take each factor using the zero factor property by setting each factor equal to 0 and then solve the corresponding two equations. So on the left, we would add 4. On the right, we would subtract 1. So we got x equals -1. And then there's one more step for the one on the left. We would divide both sides by 3. So what we have here, then we would check our solutions into the original equation. And then we would put it into our solution set using the set notation. -1, 4/3 is our solution set. Okay, so now we're going to look at some examples that are more specific to what will be on the final exam. So first off, this one says to complete the factoring. Notice it's just an expression. So remember, the other types will ask you to solve. So you actually got to factor it, and then you've got to use the zero factor property. This one wants us to just complete the factoring, and it gives us a big hint over here by giving us the first factor. So the idea here, we've got a leading coefficient of 1. So what we do is list the factors of the last term, 20. We're looking for factors of the last term, 20, that also sum up to the middle term of 9, and that's 4 and 5. 4 and 5 will do it. So 4 plus 5 equals 9. So we can move directly into our factored form here, x plus 4 times x plus 5, which fits in nicely over here into our solution. Now this is the one that's a little more challenging, but it is asking us to factor. So notice we have a leading coefficient that is not 1. So the best way to approach these things is to use the AC method. So here we go. So, but the first thing, notice our leading coefficient is negative. So we always, when we have this case, the first thing we always do is factor out the negative. And that becomes now negative times 6m squared plus 11m minus 21. We just change the signs of all the terms there. So now we calculate AC. 6 times negative 21. 6 times negative 21. Negative 126. Now what we'll do with AC is we're going to list the factors of AC. We list them all out. Now what we're looking for are factors of AC that will also sum up to the middle term of positive 11. Notice also we have a positive and a negative here. So that means that subtraction is going to occur in the sum. So one's going to be negative, one's going to be positive. Looking at 7 and 18, 18 minus 7 gets us positive 11. And the one thing I always do is rewrite the middle term, what's going to happen with the middle term. Because remember, eventually we're going to rewrite that middle term, 11m, as in terms of those two factors that we determined from AC. That's what we do next. We rewrite the middle term. 6m squared plus 18m minus 7m minus 21. We rewrote the middle term using the factors we determined. Then we group it. We group it into two groups, the first two terms into a group, and then the last two terms into a group. Then we take out the greatest common factor out of each group. In the first group, the greatest common factor is 6m. And the greatest common factor in the second group is negative 7. We've created this common term of m plus 3. So now we factor out the m plus 3. And now we have the completed factored form of this trinomial here. Negative 6m minus 7 times m plus 3 using the AC method. A little bit of work to follow, but if you follow the steps the same way every time, you'll always end up in the right place. That's one reason why I really prefer the AC method on these types. Next one is asking us to factor. The first thing we notice right off the bat is that it is a binomial. So if it's a binomial, remember the first thing we do is check and see if it's a difference of squares. 64 is a perfect square, right? So we can write this as c squared minus 8 squared. So this is a difference of two squares. So we're going to apply this formula here where we have x squared minus y squared. Factors into the square root of the first plus the square root of the second times the square root of the first minus the square root of the second. So we rewrite this as c minus 8, c plus 8, and we've just factored that. And then here is the situation where it asks you to actually solve the equation. So not only do we have to factor this quadratic, we also got to apply the zero factor property to end up with the solution set. But first we've got to factor that quadratic. So what we do is and this happens to be a situation where we have a 1 as the leading coefficient. So what we can do is just simply look at the factors of the last, of which is negative 40. So 1 and 40, 2 and 20, 4 and 10, 5 and 8. We're looking for factors that will sum up to the middle term of negative 3. We have two negatives, so that implies that one's going to be positive, one's going to be negative. So what we do here, if we look closely, we can take 5 and 8. We can do negative 8 plus 5 gets us negative 3. So what we do is move right into our factored form here, r minus 8 times r plus 5. And we could mentally check this, especially the inner and outer, and see that if we were to FOIL this, that it does result, go back to the quadratic that we had before. Now we apply the zero factor property. That means we set each one of these factors equal to 0. Setting each one of the factors equal to 0. So on the left, I would add 8 to both sides. And on the right, I would subtract 5 from both sides. So the solution set is the set of 8, negative 5. So be careful whenever this say to solve the equation. Remember, it'll be set equal to 0 oftentimes, or you'll need to put it into standard form. But remember, when it says a solve equation, not only does it want you to you have to factor, but you also have to use the zero factor property and end up with the solution set here.